And of course, computation using machine learning algorithms can only be done using a data, which we call dataset. Dataset are of different types. We have what we call supervised, semi-supervised, and unsupervised datasets. Supervised datasets are datasets that are already labeled into normal and abnormal datasets. So basically into zeros and ones when it comes to machine learning. Or we can say into yes or no, or true or false, basically into binary. A semi-supervised dataset is a set that have some part of it already labeled to be normal, but the remaining part is not labeled at all. So basically, partial labeling of the dataset is called semi-supervised. So that means some part of the dataset already are classified as one, while the remaining part of the dataset is neither a one or a zero. Then the last one is unsupervised. Unsupervised is a dataset that is not completely labeled at all. So we don't know each stream of the dataset, or we can say each instance of the dataset. We are not sure if it is a zero or a one. We are not sure until we have to go through what is called pre-processing, and then we can go to the classification section. So in case if you are using the Weka algorithm, the Weka tool, which we are going to use in this lab, the pre-processing is done in the first menu and the classification is done in the second menu. And if you go through it, you can see the section of supervised and the algorithms that does for you the supervised learning. And of course, we have another section for unsupervised. So, but don't worry, we are going to open the Weka tool and we will see how it works uh, from here. So I'm going to the lab manual quickly. In the lab manual, this is lab 6, and the lab is called Weka for network anomaly detection problems. So we have the objectives of the lab, basically to install the Weka tool for network anomaly detection problem, to know how to use the Weka dataset, and to pre-process the dataset using Weka for network anomaly detection problems, and then we go to classification. So always you have to do the pre-processing, then you go to the classification. After classification, then we have the trainings, how to train the algorithms, how to train the algorithm using the dataset, and then we can try to see how we can visualize the patterns from the graph generated by the Weka tool. So this is our objective for this lab. So in case if you have the lab manual, you can simply go to the official website of the Weka in order to download the Weka tool. So let me open it and let's see how it looks like. Let me just copy the URL and then take it to the browser. And of course, we can click. So this is the website. Weka Wiki is the website. If you open this website, you simply had to go scroll down. There are different versions. So we're gonna look for the Windows version. This is the Windows version. Okay, you can simply click here to download the Windows version. Yeah, so it takes you here, and then you can basically see the Weka that you can download. So it's already downloading on my screen. And anyway, I already have installed it on my device, so you can go through the installation process. So I will come back to this part. So the installation process, once you click on the executable file, is gonna open this, and it's a simple installation basically. Once you download it and you click install, it will install for you the Weka tool immediately. Once it's done, You will see it at the desktop as C. Yeah. So you will simply see it if you type Weka. Yeah, so it looks like this. Weka is actually the bird. This little bird is the Weka. So if you click on it, it's gonna open for you the Weka tool. The Weka tool is a machine learning tool that contains different machine learning algorithms, and it has also data sets in it that can be used for experimentation. So this is how it's open. I don't want this to show again, so I'll simply say, okay. So I will expand to the screen. This is the screen. There are different sections in the Weka tool. There is Explorer, there is Experimenter, Knowledge Flow, Benchmark or Workbench, and Simple CLI section. For this lab exercise, we are going to explore only the first part, which is the Explorer. So you click on the Explorer. Once you click on the Explorer, just wait a little, and this interface will open. So you need to expand it. So this is basically the Weka interface. It has menus such as pre-processing. This is when you want to pre-process the data into or the data set into zeros and ones. And this is the classifier. This is the clustering. Classification is the section that you have the algorithms that will classify each instance of the data set. In the case of the network, each packet coming into the network into the zero or a one. That means into a normal packet or an attack packet or a threat. So this is the section that will do this for you. Then, of course, we have the clustering. Clustering is clustering algorithms. Then we have the associate, and then we have the select attributes where you can select different attributes. Then we have the visualizer where you can visualize the data set in the graphical form. So another important thing that I need to mention, I will go back to the slides a little. Classification in dataset is done according to some parameters. The parameters that are used for classification are, let me quickly go to the parameter section. Yeah, these are the parameters. The most important one is the accuracy. Then we have, of course, the true negative, false positive, false negative, and true positive parameters. These parameters, we are already familiar with them in the previous section. And of course, we have the recall, and we have the precision, and then we have the F measure. These are the parameters that will help us to determine if our classification is correctly done. Of course, accuracy is rated between a 0 and 100%, while true positive, true negative are basically 0 to 1. 0 to 1, yeah. So basically, precision and recall also 0 to 1, or sometimes converted to 0 to 100%, depending on the type of calculation that you want to use. So basically, these are the things. So we need to know this. This is the formula for true positive rate, false positive, false negative, and true positive and true negative. But you don't have to know this formula. Already is computed or programmed into the Weka tool. So we simply have to select the parameters and the calculation will be done for us. But for the purpose of knowledge, we need to show the formulas. And if you want to calculate the recall and the precision, this is the recall. The formula is true positive divided by true positive plus false negative. Precision is true positive divided by true positive plus false positive. That is the formula. While the F measure, or what is called F value or F score, is 2 multiplied by precision multiplied by recall divided by recall plus precision. So once you have this, it will calculate for you the F value. So these are the parameters. Then we have to go to the interpretation. If you're using the Weka tool, this is where you can find it. I will demonstrate this when I go back to the tool. So I'm coming back to the Weka tool. Now, the thing is, there are two different types of data sets that we can use. That's a data set for experimentation that comes together with the Weka. And of course, in the real environment, we need to extract the data by ourselves by capturing network traffic and converting it into a Weka readable format, which is extension of .csv or extension of .arff. ARFF is basically the most commonest Weka extension or format which you have to put your dataset before you can use it on Weka. However, for the purpose of this experiment, we are going to simply use the Weka dataset, which is already in that format, so we don't have to go through the formatting. So to go and get for us to be able to use the Weka, according to the lab manual, onto the lab manual, we are going to use the dataset called unbalanced.arff. And this we can find it at C, and then we have to go to program files and then Weka and then dataset, and we have to select unbalanced. Actually, in this data folder of the Weka, they have different data sets that applies to different areas of life. So let's see how it works. So I go to open file, and then I had to go to C. This is C, and then I go to program files, and then I go to Weka. This is Weka 3.86. Yeah, so this is the data. This is where the data set is. So these are the data sets on Weka. You can see airline data set, breast cancer for medical, contact lenses for eyes, CPU activities, cause for network. Then we have the CPU with vendor, credit card issues, diabetes, detection of anomalies in diabetes. So all this, but in this experiment, we are going to use the unbalanced data set. So we simply click on unbalance, and you can see from the bottom, the data set is already in the format that can be recognized by Weka, which is .arff. So we click on it, and then the instances and attribute of the dataset have been loaded correctly into the Weka. So what do we have here? We have the dataset interpreted in graphical form, and you will see the means, maximum, uh, minimum, standard deviation of the dataset. And of course, by the other side, you are going to see the attributes of the dataset. It has 33 attributes. And of course, the dataset have a number of instances, with some. Yeah, the number of instances is 856. That's the number of times that this data set was captured. But we look at this. This is by the left hand side of the screen. You will see the 33 attributes are here. So these attributes, we have to select the attributes we are going to use. It's not everything in the data set that actually applies to every situation. No. Depending on the type of problem you are trying to solve, you have to select the attributes that align with that. So basically, for example, if you are trying to do anomaly detection of DDoS attack, you have to look at what are the features of DDoS attack that are contained in this data set, and these are the ones you are going to check like this. Okay, so as you check, you will see that the graph will be changing. So for example, in DDoS attack, you want to see the traffic. So which type of traffic, maybe ICMP traffic is related to the DDoS attack. So you need to scroll and look for the ICMP, and then you check it. Maybe you want to check the throughput, the volume of the traffic. All this need to be checked as part of the attribute. But in this case, this is an experimentation data set. All these are not contained. So basically what we said in this lab exercise is you can choose any 5 attribute at random and try with it and see how it looks like. In the subsequent class, we are going to use a real-time data set, a real life data set where it contains all the attributes that we need in order to basically practicalize with it. So I will select maybe the first five attributes, 1, 2, 3, 4, 5. So the first thing we need to do is pre-processing. So I need to go to pre-processing, and then I need to choose the type of algorithm, machine learning algorithm that I have to use. So I go to choose, and then I go to filter. On the filter, I will see supervised and unsupervised. Now I want to use supervised learning. So I simply go to supervised, and then I go to attribute, and then I will see different types of supervised learning algorithms. We want to convert this information from binary, from normal to binary. So I will choose nominal to binary. This is the algorithm. So once I choose it, you will see it will appear here. Nominal to binary is chosen. So, but again, this is not done yet because you need to apply. So you need to apply. Once you apply, you will see that the graph will change automatically, showing that the pre-processing has been done. So I will apply. Yes. So pre-processing has been done now. If the dataset is quite long and heavy, it will take a longer time, and you will see the bird here, that's the Weka bird, will be moving, showing that it's still processing. So you can always see the Weka bird at the bottom right hand corner of the screen, it will be moving. But now it stopped, showing that pre-processing has been done. And you will see that the standard deviation is changed. Mean, maximum, and mean, maximum, and minimum already also is changed based on this. So we are done with pre-processing. After this, what next? We are going to the classification section. So I go to classification. After pre-processing, I go to classification. So I click classify. After classification, I will need to choose the type of algorithm that I want to use for classification. So I also need to go to choose. Okay, there are different types. My system by default picks are 0R, which is one very important algorithm, but many others are available. So let me show you the many other algorithms. Let me go to meta. On the meta, you will see different types of algorithm available. Random committee, randomized, random subspace, all these are very good algorithms. But also, for those that are very familiar with machine learning, we have the naive Bayes. The Bayes algorithm, that's where we have the naive Bayes algorithm. All these are also very much in use. So you can use any of these. Let's explore more. Let's go to functions. Under functions, you can see the SMO. SMO is also called SVM. SVM means support vector machine. It's one of the most popular algorithms and also is very powerful when it comes to classification. So I will close all this and then select one only. Um, so I will go with the default one, which is 0R. Okay, so I select 0R and it appears here 0R. 0R algorithm is selected um, for the purpose of classification. So after this, I need to select how the data will be divided because the machine learning on Weka, it will be divided into different folds. So I go to cross validation and I can change how many folds I want the dataset to be divided before it is processed by the algorithm. By default is 10, so I can change it to 20, or depending on the type of research, we can check other similar research and see how they do the basically the settings of the cross validation. So sometimes the cross-validation is actually obtained from research papers, but because this is an experimentation for lab exercise, we will leave it by default at this, or we can simply change it to percentile. Our 66 percentiles split is the most commonest and the default. So we can change also to this and it will still work, okay, and give a good result. So for now, I will leave it at cross-validation tenfold, and then I go to more options. More options is where I need to select the parametric values or evaluation metrics. That's accuracy, false positive, as I already show you on the slide. So if I click, let me do it again. If I click more options, it will open this for you. And then you need to go to evaluation metrics. So you click evaluation metrics. So these are all the evaluation metrics that are in there. I will expand it. You will see all of them. I will deselect all. Correct, incorrect simply means accuracy. Accuracy in Weka is called correct classification. Incorrect classification is inaccurate classification. Okay. Then I go down. If I go down, 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 I will see my true positive, false positive, precision, recall, F value, okay, rock area. So all these are some of the parameters that we already discussed in the class in the slide as well. So, but for the purpose of this exercise, I want to stick to what we have in the lab manual. So according to the lab manual, we have basically basically a table that we have to fill. This is the table. What do we have in the table? We have true positive rate, false positive rate, precision, recall, and rock area and time. So I don't have accuracy. So I will add accuracy here. Basically, I will say accuracy. That makes it a bit more comprehensive as we have in the slides. So we have accuracy, true positive, true false positive, precision, recall, rock area, and time taken. So I go back and choose only these ones. So I have correct, incorrect is basically the accuracy. True positive, false positive, precision, recall, uh, F measure. Do we have F measure on the table? Okay, we didn't choose F measure, so I'll go to rock area. So I will simply deselect this. I take rock area. So I have this. Yeah, and of course, if you choose this only, correct classification, still okay. That's the accuracy. But I'll put it correct, incorrect, no problem. So basically, these are the selected parameters. The formulas are shown in the slides, how they are calculated, but in the Weka, the formulas are already programmed. So basically, the Weka will calculate for you this value. So I go to OK, and then I say OK again. So basically, I finish with the settings of the parameters or the values or evaluation matrix. So the next thing is to run my experiment. So I will simply go to start and then run. Yeah, you can see at the bottom, the Weka is stopped. So that means that it's complete, basically. The experiment is finished. So I check the result. We have 33 attributes, 856 instances of the data set, and we selected only 5 different data sets. So this is the time. So you can see 0.054 seconds was used to build the model. So this is the time. So we can simply come here and say, let me put it here, 0.04 seconds was used. I will delete all this. Yeah, 0.04 seconds was used to build the model. Then what else? We need to look for the classification accuracy. So this is the accuracy. Correct classification is 98.5981%. So I copy this and then I put it in the table this way, the percentage of accuracy. Okay, good. What else? I need the true positive, true negative. This is the weighted value basically. So I go to true positive rate to positive rate. The weighted value is 0.986. I take it and then I move it to my table. To false positive rate also. False positive rate, I will need to go here and take the weighted value. Basically the same value as the true positive rate. The precision was not calculated, it's simply saying it's not found. So I will simply use the data. The recall was calculated, so we need to check the recall. This is the recall. And then the rock area. The rock area was also calculated to be 0.432. Mind you, this is a small data set, so some of the values will look the same, but there is no issue. It's for experimentation to see if you can be able to use it correctly. So this is basically the first experiment. So after this is done already. You need to repeat this experiment with different settings or by changing the different algorithms. You need to repeat it 10 times, okay, using tenfold cross-validation. So you need to set it cross-validation tenfold. You can change the algorithms, no problem. And so that you can have different values because it's likely you would have the same values because this data set is not large. It's just an experimentation data set. So once you finish, you need to calculate the average. You need to calculate average by adding all the columns and then you divide by 10, you put the value here, add all the columns here, divide by 10, and then like this. So this basically will give you the average of the experiment once you run it 10 times. So how about visualization of the anomaly patterns graph? So we need to go back to the Weka. Okay, let's visualize what we have run. So you need to go to visualize. Okay, these are the different patterns of the different attributes of the data set. You can scroll down, you will see a lot of it. So these are for each instance, okay, how it is run. So you can choose anyone for the purpose of experimentation. Just double click on it. It's gonna open. Once it's open, you will see the graph. So you simply screenshot this. Just one is okay, just to demonstrate, and you can simply put it here. Okay, so we can screenshot. Let me screenshot this, and then I can put it here. Or you can use the sniping tool. You can snipe as you wish. So if you look at basically this graph, you will see that the points are concentrated around certain region. This shows that this is the normal region. Other points that move out of the graph are basically an outliners as we explained in the slides in the previous class. So you will see the outliners. These are abnormal activities from the that are detected from the data set, basically. So this data set implies that there's a normal region here. And if you look at one point is out here,